grade, but that means they're not teaching well.
Yeah, that's true too. Definitely. Ooh. 1 to 2 midterms per week. Yeah, I feel bad for you guys. Alright, so today we're going to be doing kind of like a workshop kind of thing. So this workshop is going to be on plotting, and it's also going to be on some new stuff too. So we're kind of incorporating a lot of the things that we've already learned, like plotting and using arrays, and then we're going to be learning some new things as well for like new functions basically. Alright, and then there's a question in the Discord for when the quiz is. So the quiz on plotting is on this upcoming Monday. And that's all on plotting. It's going to be based off of the homework as well. I also saw a question on Discord for how to do the polyfit question. So we went over polyfit. I think that was the last class. So you're going to want to look at these slides here for plotting, and it's probably towards the very end. Let's see if I can see it really quick. Alright. It doesn't want to load. Oh, there we go. Yeah, so right here, slide 63, we used polyfit. Okay, so today you're going to want to download this data that I have here. It's called baseball data. So if we're on the home page for our course, if we're on the home page right here, click on the link for this week, and then you're going to click on baseball data. There's a question, can I post the homework solutions on Friday so you can have all weekend to study? Yeah, I guess I could do Friday too. I just really want to make sure that you guys attempt the homework first yourself, because I think that's more important than me posting the solutions. But yeah, I can post them on Friday. Okay, so let's download this data. I want you guys to follow along right now too, just so I want to make sure that everyone can get this data and put it in the right spot. Give me a sec. Okay, let me share my screen again. Yeah, it's a lot of numbers. It's not a big file though. I think it's like less than a megabyte, so it's still really small. Okay, so to get the data, we're going to click on baseball data. Yeah, it's not even 100 kilobytes, but yeah, it's a ton of stuff. Okay, and then we're going to actually click on this file once it loads up here. Okay, so you're going to click on that, and then you'll save the file to wherever you're going to put your script. So for me, I'll go to 205, lectures, data manipulation, workshop, and you see that I already have the file in here, so I'm not going to resave it, but put this CSV file somewhere where you're going to have your Matlab script. Alright. So this is what some of the script looks like, but I'm going to make a new script right now. Okay, so you can either follow along if that's better for you, or you can actually, work along with me. You can watch this, you can just watch right now basically, and then you can look at the video when it's posted and do it that way, but you can follow along too, which I personally would recommend, but of course it's up to you. Alright. Okay, so you see over here that the script that I just made, it's called Batters Workshop Class, and in the same directory I have that CSV file that we just downloaded. So you want to make sure that they're in the same folder. Alright, everyone good on that part? for the question, how can we put it in the same folder? So yeah, so for that, you want to just make sure when you download this, hopefully you guys saw the video that I made, like, I don't know, a few weeks ago now for kind of organizing your files. So hopefully you have a folder for this class. So you would go in the folder for this class and then put it, wherever you want to put this, this file for the data. So you're going to save it to wherever you want to put it for this class. And then just make sure when you're in Matlab that when you make your new script, so, yep, whatever, I'm just going to save this. So when you save your new script, you want to make sure that that's in the same directory. So to make sure it's in the same directory, let's say I'm like way out here. So I'm going to go to the folder where I just saved that script file. So for me, that's in grad, spring 205, lectures, data manipulation, workshop, and then here we are. Alright, so that's how you do that. Okay, another question, is it normal that it's saved as an Excel spreadsheet? So yeah, if you have Excel installed, which I'm sure most of you do, right, it might say it should still be a .csv file, but Excel, it can open that up in Excel. So it should still be a .csv file again, but if it's a .xls file, that can also be read in Matlab too. So if you downloaded it, you want to make sure that when you downloaded it, you did save and not open. So make sure that you saved the file and you didn't just open it in Excel. Okay, yeah, so if you opened it in some program, that's okay too. So, here I have this kind of fake Excel program. So if you opened it up in some program, that's okay. Just go to save as, and then you'll save it again and wherever you want to have this file. Okay, so if anyone has any issues with this, then you can, hopefully you can work on it now, but if you don't have time, you can ask me for help after class too. Alright. Okay, so again, we're going to be implementing a lot of things that we've learned so far in the class for plotting and for arrays, but we're also going to be learning some new things as well. So I'm calling this kind of chapter data manipulation. Some of the stuff we're learning in here is from chapter 3 in the book, I believe. And also the function that we're going to be using to import our data, this is somewhat new. It was introduced in, I think, 2018 for Matlab. So as long as you have the version for 2018 or 2017 maybe, you're going to be good to go. Okay, so what we're going to do today is learn how to import data sheets into Matlab. So that data sheet that we just downloaded. We'll briefly touch on the different types of data, or the different data types that we have in Matlab. That'll be something that we expand upon more later on in the class. Then we'll learn how to do some really basic manipulation for the data sheets that we import. And then we'll learn how to find indices that meet some condition. So I know that's pretty vague, but maybe I want to find, well, you'll see in this workshop. But it can be for basically any condition that we come up with. We'll learn how can I find the index for some condition. And then we'll briefly touch on logical operators today as well. And we'll talk about those in more depth later on too. Okay, so to import a datasheet. Oh yeah, by the way, I'm planning on this taking up the whole time today. So I really want to, take our time and not rush things. So if you ever have any questions, make sure you ask it in the chat or use your mic. Okay, so starting in, I think it was 2017, the functions XLSRead and CSVRead, that's what we'd use before to import a datasheet. They were deprecated in favor of Readtable, Readmatrix, and Readcell. So all of these, table, matrix, and cell, they're different data types or data structures inside of Matlab. So a table a table can contain all sorts of different data types in that table. So in this example here, pretend that this is a table in Matlab. On this side here in this column, we have something called a string array. So it's an array that just contains words. And then in this other column here, we have a numeric array, which is what we've been using this whole time so far in the class. Right, and then a matrix, that's what we've been doing so far. That's just a numeric array. And then a cell, that's different. So a cell can basically contain arrays in each cell, but that'll be something we talk about in more depth later on. I think it's a lot more easy to understand once we actually show what a cell looks like. Okay, so for now we're going to be using the Readtable function. So this is going to allow us to import our datasheet as a table in Matlab. Okay, so here's the basic syntax. We're going to say whatever we want to make our table name. In this case, I said T equals Readtable, and then we just put our file name and make sure that you include the extension or the file type that you have. So for us, it's a CSV file. Okay, and another benefit too for a table, we can access, a lot of these different data types in one localized place. So here we have a string array here and a numeric array here. If we use a table in Matlab, we can keep both of these together in that one table versus having one specific string array for one variable and then our numeric array in another variable. And then we can also make plots directly by accessing all these values in our table by using something called dot notation, which we're going to be using today. Okay, so in this workshop, we're going to be learning how to import spreadsheets. We're going to learn our different data types, how to convert data types. So we're going to basically convert a cell array to a string array, which I'll explain why in a bit. And learn how to manipulate tables, and we're going to learn how to avoid, in quotes here, something called hard coding, which will make also more sense once we move along here. Alright, so first thing, to import our data sheet, let's make a little comment here. Actually, I'll make a section called import data. So we've already done this part. We've already placed our data sheet in the same folder where our Matlab script is going to be. We've already made our script file. We're currently in it right now. And now we just have to import our data. So I want to reiterate, make sure that your script here, so you can see my script that I just made here. Make sure this script is in the same folder as the CSV file that you downloaded. You could also technically in Matlab, you can specify the exact path in this line of code, but if you have a ton of directories, that would be a lot to type out. Okay, so I'm going to call this table batters, and we're going to say read table, and then in here we put the file name that we have. So it's called batters, and then .csv. Alright, make sure you put your semicolon at the end here, because if you don't and you run your script now, you're going to get, I don't know, it's like 1,000 rows or something in the command window. Alright, so let's run this now. And then you see in the workspace over here, okay, I guess it's 414 rows. In the workspace over here, you see that we have this table called batter. So if I hover over this, it says it's a 414 by 31 table. So let's open this up, and we'll just take a look at this. So, yep, there's a ton of numbers here. We have 31 columns as well. So we're gonna, we're not gonna obviously go over all of these things here. There's no point, but we're gonna make a nice little plot. Okay, there's a comment that says, one of yours says batters.numbers. So if it says batters.numbers, you can rename that file. So just, let me go here. So you could just right click on it and then click rename. And you can just rename it batters.csv like I have. Nathan, did you have a question?
Oh, no, nothing. Sorry.
No? Okay. Alright, so you want to make sure that it says batters.csv. Well, you don't have to, but it might be easier to follow along right now. Alright, oh yeah, so again, this is a table, right? So if I look at this if I open this up, you see here, this column that's called pitches, this is a numeric array. So it's just a column vector of numbers. And here in column 3, we have player name. And you see that we have these little single apostrophes here, or single quotes. And this is actually a cell array. So these are different data types, but we can have them in a table. So if I go in the command window and I type in class of batters, so that's our table. And I'm going to use dot notation now, which is, if I use dot notation here, basically I can access some column inside of our table. So the first column, that was called pitches. So if I do dot pitches, then Matlab tells us that it's a double. So a double is basically a type of number. So basically this is telling us that we have a numeric array for column 1. Then if I do instead batters.player name, so that's accessing column 3 here, then Matlab tells us that it's a cell, or a cell array. Okay, so we have these two different data types. Okay, so again, we used dot notation to access a different column in that table. Okay, and if I want to look at all of the values in, let's say, that column called player name, I can type in batters.player name. And if I press enter now, then you see that all of this shows up here. So it's basically every single player that we have in that table. Okay, the sizes are different. 7,499 by 367. Yeah, that's pretty different. It should be the same exact thing here. Yeah, it should be 414 rows. I'll re-download this though, and I'll call it something else. Batters test. Oops, I didn't say that in the same spot, did I? Yep, so I need to go to my folder I want to save it to. Okay. And let me import this one. Alright, yeah, it's the right size. So I'm not sure why yours says it's a different size. It almost sounds like it converted your CSV file into something else. So you want to make sure that when you download it, you just press save and save it to whatever location. Don't open it in some program and then save it, because maybe that's causing an issue there. Do other people have the same size that I do? You should have a size of 414 by 31.
Yeah, I got it.
Okay. Alright, so yeah, maybe if you still see that weird size, you can stick around after class and we'll figure out what's going on. Okay, so next thing, we talked about how you have the same size but you can't run the code. So yeah, it looks like there might be some bugs to kind of work out with some of you. I think it's probably related to importing the file. So, but it's kind of a specific use case for a lot of you, I think. So if you have an issue, yeah, just stick around after class or message me in Discord if you can't figure it out right now. Alright, so remember we looked at the column called player name, and Matlab told us that that was a cell array. So we'll talk about cell arrays again later on in the class, but for now, we're going to convert this cell array into a string array. So a string array basically is going to be an array where each kind of entry or index that we have has basically a string in it or just words in it. Okay, so for us, we want to convert this because we're going to reference this column later on. And again, just kind of trust me right now, but we want it to be a string instead of a cell. So we're going to convert this now. Okay, so to convert this column, which again is column 3, so we're going to convert all of these values here to a string. We're going to use something called update notation. So basically we're going to type in batters.playerName. That's going to access that third column. And then we're going to say equals. Then we're going to use the function called string. And then batters.playerName. And now Matlab is basically going to update this column, which is called player name, and it's going to update it to a string array. So before we run our code, I'll do class of batters.playerName. Okay, so it says it's a cell. Now let's run our code, and let's type that again. And now it says it's a string. So every value in here is now going to be a string, and you see that it has double quotes now. Okay, and currently our table isn't really sorted by anything that's useful. At least it's not clear what the default sorting is here. So it's not alphabetical. And in BA here, so BA is batting average. So I know not everyone's going to be a baseball fan in here, right? But batting average is what you would kind of assume what it means in the name, right? So it's basically just saying how often somebody gets a hit. So here, this person gets a hit basically 29% of the time. And, if you're not a baseball fan, right? Baseball is a sport of failure. So getting a hit 29% of the time is actually really good. So you'll see like the top numbers here we're going to get for batting average. Here, 33% of the time, that's going to be quite up there. So we're going to be making a plot today for batting average. And that's this column here called BA. Okay, so we want to sort our table to something that is more useful. And we're going to use the sort rows function to do that. Okay, so we're going to sort this by batting average. So, again, we were just looking at that column, which is column 6 here. And basically, I want to sort this entire table to where our first row here is going to be the player that has the highest batting average. So, this will be the highest number, and then it'll decrease down in for the size, or the size of the number. Okay, so let's sort this now. Let's just have one little, I'll make a section, okay. So we want to sort our table by batting average. Okay, so here I'm actually going to make a whole new table now. And we don't have to do this. We could use update notation again, kind of like we did here. So we could do that again to update our table. But just to kind of be a little more visual here and not try to complicate things too much, I'm just going to make a whole new table called BA. So BA is standing for batting average. And we're going to use our sort rows function. So if we type in sort rows, you see here, this is all of the different arguments that we can have. So there are different arguments that we can use, but for now, I'm going to type in batters for the first argument, and that's the table that we're looking at. So it's going to look at that. It's going to look at our table that we currently have called batters. And now we want to tell Matlab which column we want to sort our table based off of. So we're going to say BA, right? Because that was our sixth column here for batting average. We want to sort our table based off of that. And by default, I think it's by ascending, but we want to specify that we want to have this in descending order. So we want to have the player with the highest batting average and go down to the player with the lowest batting average. All right, so let's keep, actually I can just run this now because we're making a whole new table. So you see over here that currently the first player here is Jose Ramirez, and he has a batting average of 292. But if we open up our new table that we just created called BA, now we see that the first player is Brian Hayes, and he had a batting average of 376. So you see that he is the highest one, and as we go down row by row, it decreases in value. Alright, so we've sorted this entire table now based off of this metric for batting average. Alright, everyone clear so far? Okay. I'll take your silence as yes. Hopefully. Okay, so now we're going to use array addressing, or we'll first talk about how we can do array addressing inside of a table. Okay, so to do this, we can basically combine our newfound skill of using dot notation, and we're going to combine that with what we've learned before for how to use array addressing. So I'll just go in the command window here because we're actually not going to use this variable later on. But let's say that for our table that we just created here, that I want to get the top 10 players for batting average. So basically I want to get the first 10 rows right here. I want to see the top 10 players that have the highest batting average. So I want to get all of these players. So to do that, I will go here, I'll go in the command window, and I'll just call this variable, whatever, it doesn't matter. But I did T10 BA for top 10 batting average. And we're going to type in our table that we have. So that's BA. We're going to use dot notation for the column that we want to look at. So player underscore name. And now we're going to use array addressing. So I want to get the first 10 people. So we're going to do 1 to 10. And also, we're accessing a column vector, basically. So that's one dimension. So I only need to specify one dimension for this array addressing. So really, in this case, I'm specifying the rows that we're getting. I don't need to specify the column because it's just a column vector itself. Alright, so let's run this now. Okay, and then here we go. We have a 10 by 1 string array, which is all of these people right here. And you see that they match up, right? It's all these first 10 people that we see here. Okay, so that's how we also combine array addressing with the table. Okay, so all of this stuff so far is going to be important for your project, which we'll talk about. I think I said we'll talk about it next week. Yeah. But you're going to be using a lot of these skills then. Okay, so here is the goal. So this is what we want to do for this workshop. We want to create this plot here. So this is a stem plot, if you remember this from, I don't know, a few lectures ago. And we're going to get the top 25 players by batting average. So we've already sorted our table by batting average. And we want to limit this to where each player had at least 100 plate appearances. So you don't need to worry about what that really means. But basically we're going to modify our table to only have players that had 100 plate appearances. Okay, and then we're going to plot them, and we'll get all of their corresponding names down here. And you see on this axis, it's their batting average. All right. Okay, so again, we want to restrict basically our table right now. So we want to look at players that had at least 100 plate appearances. So again, if you don't know what that means, you don't need to worry about it. We're going to look at that column though, which is ABS, column 14 here. So ABS stands for at-bats. So basically we want to modify our table to only have players that had at least 100 at-bats. I said plate appearances before, but we're actually modifying this for at-bats. Okay. So we'll look here, and so this first player, he's going to be gone. We want him to be gone. Oh yeah, this is just one season. I think this is from 2020, so it's a shortened season, so that's why some of these people have really high batting averages. Yeah. Okay, so we want to get rid of this guy because he only had 85 at-bats in this season, and you see that a lot of people, they had more than 100, which is what we want to do. Okay, so if I keep going down here, you can see that, you know, these three people, they gotta go. This guy's gotta go. Alright, so there's gonna be a fair amount of people that we want to take out of here. Okay, so to do this, basically we need to determine if each player has had at least 100 at-bats. And to do this, we're going to use a logical operator. So let's make another section here. We'll call it minimum of 100 at-bats. Okay, and I'm going to call this L100. Call it whatever you want, but basically for, you know, at least 100 at-bats. That's how I think of it. And we're going to access our table right now, so that's called BA. And then we're going to access the column for at-bats, which was .abs that we were just looking at. And we want to make sure that, or we want to check if this is greater or less than 100. So basically here, I'm telling Matlab to look at that table for at-bats. And if it's less than 100, it's going to give me a 1, which means true. And if it's false, it's going to give us an answer of 0. So if I run this and I look at this in our workspace, you see the first value that we have is a 1, so that means true. The second value is a 0, and so on. So let's take a better look at this here. Okay, so again, we're looking at this column over here. Let me go to it. At-bats. And we want to check if it's less than 100. And if it's less than 100, we're using our logical operator up here, which will give us a logical answer of 1, which means true, or 0, which means false. Alright, so for the first row, or for the first player, Matlab is, you know, it's going to look at it and it's going to say, is 85 less than 100? Well, yes, that's true. So it gives us a logical answer of 1, which means true. All right, and then columns 2 through 5 here, they're all greater than 100. So Matlab is going to say, okay, that's false. All of these are greater, or basically all of these are not less than 100. So it gives us an answer of 0. All right, and then the next one is 49. 49 is less than 100, so that's true. Matlab gives us a 1. All right, so does this part make sense? Because, you know, it's some new stuff here. Okay. All right, so now we know if a player has or hasn't had at least 100 at-bats, but we want to restrict our table, so we want to modify the table now to basically delete all of the rows for those that didn't have at least 100 at-bats, because we don't want to look at them. We don't care about them anymore, right? So we want to take them out. Sounds very aggressive. So we'll say, let me put a comment here. Find if each player had at least 100 at-bats. And then we're going to make a new comment. Delete rows for players that don't have at least 100 at-bats. Okay, so in all of your scripts, you want to make sure that you have a lot of comments throughout to make sure that you can look at your script later on and you know what you're doing in each part of the script. Okay, so now we're going to delete all of the rows for the players that don't have 100 plate appearances. So remember, if we look at this first row, this player didn't have 100 at-bats. I should have said at-bats. So we want to delete this entire row. Okay, we want to take all of this row out because we don't care about this guy anymore. He didn't have 100 at-bats. And we want to do that for every single player, or basically every single row, where the amount of at-bats was less than 100. Okay, so to do this, we are now going to say, we're going to look at our table, which is called BA, and we're going to reference our variable here. So we're kind of using array addressing right now. So the variable that we just created was called L_100. So that's the rows that we have. Okay, and then we want to get all of the columns here, and we want to delete them all. So to delete something in Matlab, to basically delete a row, we use these square brackets, these empty square brackets, and that tells Matlab that we want to delete that row. So what it's doing here is it's deleting every single row here if there is a logical answer of 1, which means true. So basically, our first row, that had a 1, so Matlab is going to look at our table BA here, and it's going to delete this entire first row. And it's also going to delete the entire 6th row, because that player also did not have at least 100 at-bats. He had 49. So he's got to go. Player number 8, he had 82 at-bats. He's got to go. So Matlab is going to look at this table at kind of in one pass here. And if this value was true, it's going to delete that row. Okay, so let's run this and also take a note of the size of our table right now. We have 414 rows and 31 columns. So the amount of rows should change because we're taking some of them out now, but the amount of columns, they should stay the same, right? So let's run our script. And now this table is now modified to have only 281 rows. So if we look here to at-bats, all of these players have at least 100 at-bats now. So if we scroll through here, we shouldn't see any players that have less than 100 at-bats. And you see that that's the case. Okay. Yep, so if there's a 1, it gets deleted. Yeah, that's right. So we're basically looking, remember a 1 in this case, it meant that it was true that a player didn't have 100 at-bats at least. And we want to delete all of the rows or the players that didn't have at least 100 at-bats. So yeah, when we use this delete notation here, Matlab is looking at this logical array here, and basically it's using array addressing in such a way that if it has a 1, which is true, it's going to take out that corresponding row in our table. Okay, so I know that this is kind of a lot of stuff to take in right now, so you might want to look at this video again if it's a little much right now. Okay, so that's what we did, and now we're going to do some more familiar stuff. So now we're at the point where we can actually make our plot. I guess not quite yet. We're almost there though. Okay, so at this point, we're going to talk about how we can avoid hard coding. So for our plot here, we want to look at the top 25 players by batting average. So remember, we wanted to make this plot. So we have 25 players here. So, we can go into Matlab, and I could say plot. Actually, it would be stem. So I could say stem BA, that's our table, dot player name. And then we would do, actually I shouldn't do that, I should do BA dot BA for batting average. And then I could do 1 to 25. Okay, and if I do this right now, let's just run it. Oh boy. we're going to do figure and a visible on. Okay, now let's run it. And here we go. We have a plot, right? This is a plot for the top 25 batting averages. So if we look at our first one here, that's 373. Let's make sure that that corresponds with our table. So we'll go to the column called BA, and look at that, it's 373. The second one is 364, and that's what we also see in our table. Alright, so we could do this, but let's say later on I want to plot the top 50 players. I would have to go here and modify this to be 50, which in this case it's fine, I only have to change one line. But you'll see later on throughout our code, we're going to be referencing that number 25 multiple times. So later on, if I want to change this to the top 50 players, basically I only want to change one line of code and not multiple lines of code. So we're going to instead create a variable here called top to basically represent how many players we want to plot. And you'll see later on that, again, we're going to be referencing this variable multiple times. And again, this is going to help us, so we only have to change one line of code and not multiple lines of code. Okay, so let's make a comment here. Variable for the amount of players to show in our plot. Okay, so I'm going to call this top, and I'll set that equal to 25. So this is, again, representing that we want to plot or have a plot that shows 25 players. Okay, so I'm going to let you guys work for a little right now to try to make this plot. I actually already showed you how to do it. It's kind of useless then, so we'll just go on. Okay, so we're going to make this plot here, but you know, what I just showed you guys was doing 1 to 25. Now we're going to reference that variable top that we just created. So let's make a new section and call it plot. So to do our basic plot here, we're going to use the function called stem to create a stem plot. And we want to look at our table called batting average. And we want to plot the column for batting average, so that's BA. And I want to have 25 basically plots here. So I'm going to do 1. And instead of putting 25, I'm going to put top, which, you know, we defined on line. Ooh, we also defined that on line 25. Nice. So we're going to say go from 1 to top, which means 1 to 25. Figure visible on. Okay. There we go. Alright. Everyone good so far? Okay. Okay, so we're going to change this now to, instead of having blue lines. Okay, yeah, just trying to follow along. Yeah, I know there's actually a good amount of new stuff here. I know. So now we want to make a plot here that's solid black circles basically up, you know, up top here. So instead of being blue and having hollow circles, we're going to make them black lines and then filled in with a black circle. Yeah, there is a lot of new commands here, huh? Pretty much on every single row here, we did something new, I guess besides this one. Alright, so we're going to do K. K means black. And then we're going to put in another new command here, or argument called filled. Yeah, if the data table didn't work for you, yeah, it would be tough to follow along. Okay, so if we do that, then now we have this new plot here that has black lines, and it's filled in with black circles up top. Okay, so now what we want to do is modify our graph to look like this. So this is now going to be referencing basically all of the skills that we learned, I don't know, either last class or the class before. So you see here, this is what we currently have, and we want to make our plot now look like this. Let me run this again so you can see what we currently have and what we want to have. Okay, so you see here that our X ticks, they're changing. Right now, we don't have 25 ticks. So we want to have 25 ticks here. And also, you're going to have to change the X limit. Because you see here at the very end, this last player, he's right on the edge. So you're going to have to modify your X limit as well. And we're also going to modify our Y limit to go from 0.3 to 0.4. Instead of here, it's going from 0 to 0.4. So you want to change that too. And we're also going to change our Xtic angle to a 45-degree angle. Okay, so all of this now that we're doing to make this plot here, this is everything that we've talked about in the plotting chapter. Okay, so I'm going to give you guys a few minutes to work on this, and then we'll go over it. I'll give you, it's already 3:20, so, well, almost 3:20, so I'll give you, I don't know, four or so minutes to work on this part. Actually, I guess I should first check. Is anyone actually following along in Matlab themselves?
Yeah.
Okay.
Yeah.
Alright.
I'm just gonna go rewatch the lecture.
Yeah, I'm sure a lot of you probably will, which is good too. Okay, so I'll give those of you that are following along about 4 minutes to do this part. And if you guys are just watching, which again is good too, I don't know, maybe if you had an issue with your data sheet or something, you can try to work on that part too. Or just chill out. Okay, there's a question. Should I try to import my numbers graph to Excel? So if you opened it in Numbers, which I think on a Mac is like their kind of default fake Excel program, right? So if you ever opened in there, you can just do File and then Save As and save it as a .csv file and put it in the same folder that your script is going to be in. And that should work, but Numbers, maybe it's kind of doing some conversion on the fly and it might mess up the formatting. But you can try that, and if it still doesn't work, then stick around again after class and then I'll help you out. Okay. Yeah, it seems like share your screen with me after class and then I'll see what's going on. Because it sounds like if it's fine on Numbers, then it sounds like it's doing some kind of conversion in between. Alright, give you guys 1 more minute. Okay. Alright, so hopefully you made some progress on this, but we'll go over it now. You know what I could do actually? Let's do this. So something that's kind of annoying, if we use the command called visible and then on, if we run the script and I run it again, it always creates a whole new figure, which is really annoying to me. And I've been trying to look this up for how we can use this command and basically just update the figure again and again, but apparently it's very complicated to do in Matlab, which is annoying. So for the moment, I'm just going to call this figure 1. And if I do this and I keep running it, you see it's not making a whole new figure, it's actually just updating this figure that we have, which is a hell of a lot more convenient. So I'm just going to leave this over here, just so we can keep running our code basically, and updating that. Okay, and yeah, basically if I add on visible and then on, then there's an error, of course. So, I don't know, kind of weird. At this point, your table should be 281 by 31. In the beginning, it should be 414 by 31. Okay, cool. Alright. So the first thing that we have to do, we already made our stem plot, so we're good there. And now we're going to adjust our y limit, because we want to make this go from, what was it, from 0.3 to 0.4, which basically is from 300 to 400 for the batting average. Okay, so we're going to adjust our y limit. And basically this, we're going to go for a minimum of a batting average of 300. 300. Because, you know, all of these players, right? 0, that means a batting average of 0, that they never have gotten a hit. Well, we're looking at the top 25 players, so all of them have, and they all have a good batting average. So we're going to put our minimum y limit to 0.3. Okay, so we're going to use our ylim command. And then we have to use square brackets here, so we're going to do 0.3 to 0.4. So now if I run this, you'll see this will update over here. And there we go. We go from 0.3 all the way up to 0.4. Okay, next thing we want to adjust the amount of Xtics that we have. So basically I want to have a tick mark for 25 players. Okay, Xtics for all players. And this is going to be the second time now that we're going to reference top. So we reference top right here. We're also going to reference top right here to be, so Xtics from 1 to top. So this is a good point already where we want to avoid hard coding. So let's say later on I want to, instead of plotting 25 players, I want to plot 50 players. I would now have to change 2 lines of code to be like 1 to 50 right there and 1 to 50 right here. And you know, we want to avoid all of that work. So we're going to have it be 1 to top. So if I want to make it 50 players, I would only need to change this 1 line of code. Okay, so there's the Xtics. Well, let's run this. So you see now it updates, so we have 1 to 25. And my stomach is growling. Okay, but we want to adjust this because, you know, this last player, he's right on the edge of our axis. And, you know, that's not good. So adjust xlim so the first and last plot aren't on the axis. On axis, I don't know, limit. So if I do xlim and I'll do, if I do 1 to, I'm going to demonstrate this. So if I do 1 to top plus 1, so basically I'm gonna put top plus 1 because I want to have a little space over here. So if I do this, now this guy, our first player, he's on the edge of the axis, and that's because we're telling Matlab to have our limits start at 1 and then go to basically, in this case, 26. But we really want to start it at 0, so this guy isn't right on the edge. So let's run that, and there we go. Now it's nice and spaced out. And you see that again, we're referencing that variable top. Okay, and then the next thing we want to do is just the angle for the Xtic labels. So angle for Xtic labels. And we're going to use our command that we learned before, which is Xtic angle, and make that a 45-degree angle. We'll run it, and there we go, it's 45 degrees. Alright, next thing we want to do is have the player names for all of these Xtic labels. So we're again going to avoid hard coding here, because I don't want to look at our table and type all of these player names in manually. I mean, even just 25 players, that would take, a good amount of time, right? So we don't have to type it all out ourselves. We can reference our table. Jeez, my stomach. So we're going to reference our table here to get all of these player names. Actually, not this table. This table. So all of these player names. And that way we don't have to type it out ourselves. Alright, and then we're also going to make a title, of course, as well. Okay, question, are we going to be using these commands for the project? Yeah, so some of them you will be using. Something like Readtable for sure, right? Because we want to import our data. Converting to a string. I mean, I guess who knows, but that's likely to happen. Sort rows for sure. And logical operators, you may or may not use a logical operator. It kind of depends. Deleting rows, that might occur too. So yeah, a lot of these you will use in the project, at least to some capacity. And then basically this part, you want to make sure basically that you're keeping that methodology in your head to avoid hard coding, because that's going to save you a ton of time. Okay, so we want to, and also what we're going to show right now, this technique to basically have these Xtic labels where we don't need to type it all out ourselves. That's going to be very useful as well for the project. So remember, last semester I had a project on COVID-19 data. Basically imagine that all of these were like different counties or something, county names. And day by day, the amount of COVID cases, let's say, that might shift. So if one day one county has the highest amount of cases, and the next day a different county has a higher amount of cases, they would flip spots, right? So if you were hard coding, if you were typing in the county name yourself, you would have to keep up to date with this, and you would have to modify, are they the first county or are they the second county, and so on. And that'd be a huge pain in the ass. So if we can kind of automate this in Matlab to handle that itself, then we don't have to kind of, stay up to date with our hard coding, which takes up a lot of time. Alright, another question, can we only use codes and commands we've learned in class on the project? No, that's a good question. Yeah, so if you can think of a better way to do something, you can go ahead and use that method too. Yeah. Because there's a lot of different ways to do things in coding, and if you can think of a better way or maybe something that makes more sense to you, then yeah, you can for sure go ahead and use that. Okay, so let's get these Xtic labeled now. Okay, so to do this, we're going to use our command Xtic labels. Then I want to access the column that contains those, in this case, the top 25 players. So we're again going to reference this variable called top. Okay, so first thing we want to access the column that contains the player names. So that's ba.player_name. So, player name, that's the column. And we want to get those top 25 players. So we're going to use array addressing again and do 1. And instead of putting 25, we're going to say 1 to top. Okay, let's run this. And there we go. Now we have all of these player names. They're pretty close here, so we could stretch this out a bit, and then that looks a bit better. And so, they all showed up, and I didn't have to type out anyone's name at all. So now let's briefly talk about why we converted that column earlier on to a string. So if I comment this out, it's currently going to be a cell array. Let me do that there. I guess in this case it works, but there's going to be some cases in our project where if we didn't convert this to a string, then it would throw a fit. So sometimes it matters if it's a cell array or a string. So in this case, it was actually okay because basically each name was in its own cell. But later on, and we're not going to get to it today, unfortunately, but here we're making a string array, and if this was instead a cell array, then it would throw a fit for what we're doing later on in this next exercise. So again, sometimes it matters if we have a cell array or a string array. So I guess for our example today, it didn't matter, which is good, but oftentimes it does matter if it's a string or a cell. Yeah, so we didn't really talk about the difference of a cell array or a string array too much yet. I'll probably save that for another day just to highlight the differences more. But basically, a cell array can contain arrays in each cell. So it's kind of weird, at least in my opinion, to have a cell array for player names because it's just one basically value in each cell. So we typically use a cell array where we could have, let's say, imagine we had a cell array where we had 5 different cells, right? And within each of those cells, I can have an entire array in that cell. So you can imagine, let's say cell 1, I'll do C1, C2, and C3. So pretend that all of these were different cells, right? In cell 1, I could have an array that is basically, let's say all of these are numeric arrays. And this first one, pretend that it was a column vector of, let's say, 10 by 1. So there's 10 values here. In this other cell, I could have a column vector that had 20 rows. And in this third one, I could have an array that had 50 rows. So basically, a cell array can have an array in each cell, and the length can be different. That's the main kind of upshot for using a cell array. And these cell arrays, they can contain, any kind of array in the cell. So we could have, instead of a numeric array, we could have string arrays in each cell. So it'll be better to explain when I can more visually show you guys, but that's why I think it's a little weird to, at least at default, have our third column for the player names to be cell arrays, because in each cell it was only just one value. But yeah, later on in the class, we're going to be using cell arrays because sometimes the lengths that we have for each array is going to be different. And if we're in a table, let me open this up. So, we're in our table here and we have 281 rows, right? So basically we need to have, all of these every single column vector here has to be the same length. We need to have a length of 281. If this one, if all of these values were gone here and they were empty cells, Matlab would throw a fit. So kind of a tangent, but we'll discuss that in more depth later on. Okay, so let's plot this now. So there we go. So that's our plot, and I think that was it for that exercise. Oh no, we still want to make our title as well. So we're going to make our title to basically look like this, where it says top 25 players by batting average. So we're again going to reference that variable that we made earlier called top. So we don't need to even type out in our title 25. Because again, if I want to update this to the top 50 players at some point, I don't want to have to retype out my title. So we're going to be using a new function again, but it's going to be of use. It's going to be a function called num to string. So num to str. str stands for string. Alright, so make our title. Okay, so we're going to use our title command. And we're going to say, let's first just make a really basic plot title. So we're going to use the methods that we know so far. So I'm going to explicitly type top 25 players by batting average. And then in parentheses here, min of that should say 100 at-bats. At-bats. Okay. If we run this now, then there we go. We have our title. That's fine. But I don't want to have to type out the number 25. So I'm going to use our function called num2string. And basically what this does is it converts a number, in this case 25, into a string so it can be printed. We want to have a word, not a number, to be printed on our title. It's still gonna, it's gonna be a number, but Matlab is going to process this as a string so that can be printed. Okay, so there we go. If I run this now, it's gonna actually show us num2string in our title here. So it's currently, interpreting this that's highlighted here as just words, right? As just letters and numbers. But we want Matlab to actually interpret this as a function. So to do that, we need to close out of these single apostrophes. Okay, and now Matlab is going to be able to look at this, or it's going to attempt to look at this as a function. If I run this right now, we're still going to get an error here. Okay, so it tells us that there's something wrong with our parentheses. Okay, it even says use brackets. It's not a great error message, but it gets us started. So basically what we have to do here, and we saw this in the slides from last time, if I break up my title in this kind of manner where I have, basically some words that I want printed here and words I want printed here, and then we have our function here. If we broke it up in this kind of manner, we need to have a bracket in the front here and then a bracket at the end. Now if we run it, now we get top 25 players by batting average. So now it's printing out that number 25 as a string. But there's still one more issue. You see, it's real close, it's real smushed here. So what we have to do is put in a space over here and then put in a space right here. And now let's run it again, and now it's nice and spread out. Okay, so there we go. Now let's do a little demonstration of, let's say I want to change this to the top. Let's do 10 players first. Okay, so all I have to do now is change this one line of code, and that's it. Then I'll run this. And hey, you should have changed. Let's run this again. Oh, I did. That's why. I did hard coding here, and there was an issue. So I needed to num the string of top. There we go. And there we go. So our plot is updated to be the top 10 players by batting average. And here we go. We have all of our players right here. So this is great because I don't need to change this line of code, this line of code. Let's count this. 1, 2, 3, 4, 5. So instead of editing 5 lines of code, I just need to change one line of code, and that's it. So let's do 50 now. I'll run this. And this looks kind of insane, but here we have the top 50 players by batting average. You see down here, it gets all weird because basically these players have a batting average less than 0.3 or 300, so we would have to change that part. But we actually changed this ourselves before. Yeah, okay, so what's the difference of using just the number 25 in the command that we use down here? I think you're talking about this part, right? So, if you are, this is again so we can avoid hard coding. So, instead of actually typing the number here of 25, we just put top, so Matlab is going to reference how many players we're actually plotting from this variable up here. And then this function num to string, this is converting our number 25 into a string so it can be printed out. So if I just put top here, you see it just says top. So we have to use that function num to string. Yeah, where's Justin Turner? Is he not on this list? I thought we saw him with a good average earlier. Or maybe it was Trey Turner I saw. Where is he? Am I blind? Okay, whatever. Okay. Yeah, well, we got our boy David Fletcher on here too, so I'm an Angels fan. Okay, so there we go. You played with Fletch? Nice. So that's all. Well, I wanted to get to another exercise today, but I was kind of optimistic there. But maybe next time we'll go over this, so Angels data, because I'm an Angels fan. We're going to be using the same spreadsheet here, but basically next time we're going to work on basically making a whole new graph, and we're going to be making or using new functions again. So we're going to be using the find function, which is really important. And then also the isMember function, which is also really important. And let's see, any others we got? So we're going to make this plot, which isn't very useful quite yet. Each of these dots corresponds to an Angels player, but we want to have this modified so, we actually can see which player corresponds to which plot or which dot. And we're going to use another pretty important function called the text function. And we're going to use it in such a way that's kind of automated to grab their respective player and put them right next to each dot here. Okay, so that's going to be for next time. And also you see right here we have two equal signs. This is a logical operator as well, which we'll talk about next time. Okay, so I guess we're going to finish 2 minutes early, but yeah, so I know this was a lot today, probably. There's a lot of new commands, but they are all important, especially for the project. So yeah, you really want to make sure that you understand what we did today. So we're using a lot of things that we learned before, like array addressing and all of these things that we learned here for plotting before, but we're also learning some new things as well. So yeah, you want to make sure to watch this lecture back for sure. No, this is not on the quiz. So the quiz is only on plotting, and it's going to be based off of the homework for plotting. So, I guess some of this stuff down here, this could be on the quiz, like your limits and your Xtics and your Ytics, that could be on the quiz, but basically refer to the homework for what might be on the quiz. Yeah, this would be unfair to have all of this other stuff on the quiz. Alright, so that's it for today, guys. So don't forget to do your homework, and don't forget to study for the quiz, of course, on Monday. Alright, so thanks, and have a good day, guys. Have a good weekend.
Thank you, Professor.
Thank you, Professor. Have a nice day.
Thanks, you too.